Okay, midnight math. Whew. Okay, what we're going to do is we're going to count on this abacus. This is an abacus. This is my counting tool. With the counting tool, we're going to be counting. So the first thing we're going to do is we're going to do 1, 2, 3, 4, and then 5, and then 6, 7, 8, 9, and then 10. How do I know? Because I have my ones, I have my tens. So if I count, this is 1. So this is not 1, this is actually 10. Hey, hi, hello, tropical. And Michael. Okay, so what we're doing is we're counting on the abacus. 1, 2, 3, 4, and then 5. We have 6, 7, 8, and then 9. And then if you notice, I have my ones, my tens, my hundreds, my thousands, and my 10,000. So when I'm reading this, I have 1, 2, 3, 4, 5. All the top beat has a value of 5. And then I have 6, 7, 8, and then 9. If you notice, this is my ones. If there's a dot right here. This is my indicator. This indicator tells me that this is my ones place. So then I have my ones, and then I have 10. So just like we write, we have 10, 11, 12, 13, and then 14. Does that make sense? Yeah. Let me know if you have any questions. Why do I start over here? I start over here because my indicator is right here. This indicator is my ones place. So I have my ones, my tens, my hundreds, my thousands, and my 10,000. One of these things, it's an abacus. This abacus is a counting tool. And this counting tool, we can do adding, subtraction, multiplication, and division. And we can also do, hello everybody, welcome. We can also do some adding and subtracting. Okay. So, but the first thing we're going to do is we are going to learn how to read the abacus. So I have my ones, my tens, my hundreds, my thousands. Thank you so much for the likes. Okay, so then if I look at this is actually 14. How do I know? Because I have 1 and I have 4. So what does that mean? Anytime the beads are touching the horizontal bar, that means they're being counted. So this is counted, but none of these are counted. And notice none of the top beads are counted. Well, okay, we have 14. Well, how do we do 15? Well, 15 will always be, the 5 will always be the top bead. The top bead will always be 5. Why? That's just the way it is. Okay, so let's count. So we have 5, and then we notice all the lower beads of the horizontal bar has a value of 1. So we have this. This is 6. So we have 5, 6, and then 7. 5, 6, 7. So notice we can count, right? We have our 5 plus 2 is 7, and then 3. If this is 3 and we add the 5, we now have 8. Wow! Thank you so much for the likes. Thank you so much for joining. And we're going to be midnight math right now. I'm just looking at some questions. So the first thing we're going to do is understand how to read the abacus. So notice I have 8. If I have 8, then this is 9. All the beads, every column is a 9. So this is 9, this is 9, that's 9, 9, 9. These are all 9s. These are all 9s. But if I wanted to zero it out, now we're at 0. Hi, everybody. Welcome. Hey, Jose, the panda, you're back. All right. So again, we're going to do 1, 2, 3, 4. But now if I do this is 54. Another day, another abacus. You're absolutely right. You're absolutely right. Another day, another abacus. But I'm getting one step closer to my book, which I'm going to be, I'm still working on my book for adults. All right. So we have 54. How do I know? Because we have the top bead. The top bead is a 5. The top bead will always be 5, and the bottom beads are always going to be the value of 1. So this is 1, 1, 1, 1. But notice there's 4 ones. So if there's 4 ones, that will be 9. This is 4, this is 9, this is 5. So how do I know? We have 594. Anybody have any questions? What we're doing, we're just reading the abacus. When we read the abacus, so I have this, I have my ones, my tens, my hundreds, and my thousands. And then after my thousands, I have my 10,000. How do I know? Well, I have my indicator. This is my indicator. My indicator is my ones place. So with the ones, with the tens, and the hundreds, the thousands, and the 10,000. So if I have so here's a question for people coming in and understanding how to read the abacus. If I did this, let's do that. 6, 2, 8. What number is this? If I said that this is my ones, my tens, my thousands. I finally have my girlfriend watching live with me. Welcome! Welcome! Jose the Panda's girlfriend, I'm so happy you're here. Let me know if you have any questions. I have a question for you guys. What number is on my abacus? What number do you think my abacus is? Do you do negatives? No, I don't do negatives. Not on the abacus. Oh, yeah, you're right. James and Isaac. Oh, Mackenzie. So when we do it, we have ones, we have 5, 6, and then 9, 5, 6, 7, 8, 9, 2, 1, 2, and then 8. 5, 6, 7, 8. Yes. Thank you, Emily. Yes. Yes. Maybe because my abacus wasn't touching. Maybe that's why. But it was supposed to be this. It was supposed to be 6, 9, 2, 8. Yes. Thank you, Jose. All right. So we know how to read. Let's do another one. I'm trying to find like people's usernames. So what number is that? What username has these numbers? What number do I see? I'm just trying to find. What's up with the first two columns on the right? Oh, yes, Isaac. They are decimals. You're absolutely right. Thank you, Heroic. Yes, it's 138. Why is it 8? Because it's 5, 6, 7, 8. Welcome, Robert. Hey, Babel. How's it going? Not negative 80. Yes, thank you. Thank you, Beanie. Yes, thank you. Thank you, Jose. Yes, exactly. So, and then I'm just trying to find more words. I'm just trying to find more numbers. So if I did this one, what about this one? This should be easy, right? If I did this, and then I did this, and I did this. What number is that? Doing good. Good. Going good. Oh, good. Oh, good. Yeah, today was a nice day. Hello, Melinda. Welcome. All the old people, we're all coming back. Okay, so Isaac says 3. No, this is 2. Yes. Isaac says 1. No, this is 3. Heroic says 20. Yes. Yes, I keep missing up, Isaac. You're fat thumbing it all. Yes, Melinda. 2,327. Yes, thank you. Thank you. 27, James. So we have 5, 6, 7. If it was 9, it'd be like this. All the 9s. Yes, thank you, Jose. Wow, right? Easy, simple to use, easy to understand. We're going to do another one. Let's do another one. Let's do this one, and then this one, and that. What number is that? So again, I'm still going to say ones, tens, hundreds, and thousands. So the first thing we need to do is we need to understand how to read the abacus. When we understand how to read the abacus, then we can go forward. We can go forward into adding and subtracting, and that will be so easy. But there are a few things that we need to know. So 2,000 plus 00. 4165. Yes. Yes, Isaac, you're fat thumbing things. Also, my Daiso didn't have an abacus or the one I went to. Yeah, you might. That's what I'm thinking, Melinda. You have to kind of go around because the one closest to me, the Daiso that was around me, didn't have it. But I had to go like a few more. I had to go like further out. So they're not everywhere. You might. Yes, Isaac. You might need to ask the Daiso people if they can find the inventory for you. But yeah, those are. Not all of them carry it. That's what I've noticed. Jose, 146. Yes, thank you, Jose. Okay, so we understand how to read the abacus. Yeah. I would. Yeah, that's what I would do. I would ask them. Okay, so we're done. We're okay. Anybody have any questions about how to read the abacus? Because we're gonna go on. We're moving on. We're moving on up. Anybody know that song? Moving on up. Anyways. You can tell I'm really old because that came from a TV show. Okay, so plus 2. 5 plus 2, that's what it'd be. Yeah, same. I just joined. Could you kick a rundown? Yes, I can. We're looking at the abacus. This is an abacus. This is a counting tool. So the first thing we're going to do, and thank you so much for letting me know, Zimena. 1, 2, 3, 4. Anytime the beads are touching the 4, Jefferson. Yeah, right. The Jeffersons. Yeah, right. No, I know you're old now. Okay, so we have 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, we're counting it. So we have 4. So then we're going to go 5. What's after 5 is up here. The top bead will always be 5 no matter what. The top bead is 5. So when we count, we have 6, 7. How do I know? Well, if I remove the 5, this is 2. If I add the 5, this is 7. So then we have 8 and then 9. After 9, we have 10. This is my place value. So when I look at the place value, why do I go here? It's because my indicator shows me that this is my ones place. So with my ones place, this is my ones, my tens, my hundreds, thousands, and 10,000. It doesn't matter if you choose this indicator or this indicator. So let me know if you have any more questions. So what we're going to do is we're going to continue to count. We have 1, 11, 12, 13, 14, and then we have 15. Does that make sense, Amina? So after 15, we have 16, 17, 18, and 19. And then we have 29. Let's do, 20, 29, and then 39, and 49, and then we have 50. Okay, good. Makes sense, right? Because what we're doing is just learning to read the abacus. When we understand how to read the abacus, we can actually do some adding and subtracting. Whew, okay. Smiles the dog. What are you doing? Okay, so anybody have any questions? Questions? No questions? Okay, because I'm going to continue on. So if this number, what number do you think this is, Zamina? I'm putting you on the spot because you came in and you asked the question. Okay, what number does anybody know what this is? Anybody? Bueller? Anybody know what that movie came from? I have a lot of movies in my head. That's like old movies too. 2. No, Dave, not 2. Isaac, 6, 2, 5, 9. Yes, thank you, Melinda. You're missing the 6. Yes, Khalil. Yes, Ray. 1, 2, 5, 9. Yes, awesome. Yes, perfect. Right? Makes sense. So, Ferris Bueller's Day Off. Yes, Ferris Bueller's Day Off. Yes. I didn't fat thumb it this time. You're good. Okay, so we know how to read it. We know how to read it. Bueller, right? Yeah. Okay, so I'm not either I'm not old or you guys are old. I can't figure that one out yet. Just like the Karate Kid with waxing on and waxing off. All right. So what we're going to do is we're going to start learning to count. We are the same. Oh, okay. I don't know. I'm kind of getting up there. Nah, I just love old movies. Old movies, right? They totally rock. You know what's another movie I wanted to get the kids to watch was Gattaca with Uma Thurman and Ethan Hawke. That was a good movie. And then I was watching The Matrix again. I love The Matrix. Oh, I love The Matrix. I remember watching The Matrix in the movie theater. It was so good. Teaching. Okay, yes, teaching. Okay, so what we're going to do is we are going to... Oh, yeah, right? Gattaca. Oh, I love The Matrix. I love all of the whole series of The Matrix. Okay, so the first thing we're going to do is we're going to understand, in Abacus, we will look at the add-ins. We don't focus on the result. Now, I noticed that there's a lot of, like, math that's out there with the videos. They very much focus on the result. Whereas what we want to do is or the Breakfast Club. Yeah, I like the Breakfast Club. You know what, though? But I never really got into Pretty in Pink. I didn't like Molly Ringwald so much. But I like Michael Anthony Hall, and I really liked Weird Science. That was good. Okay. So what does this mean? What we're going to do is we're going to focus on the add-in. When we focus on the add-in, we need to understand what the number we're going to add. An add-in is just the number that we're going to be adding. And then there's a subtract head. So what about Dead Poet? Oh, yeah, I like Dead Poet Society. And then, I saw Good Will Hunting, and that was pretty fantastic. I actually never saw it when it first came out, but then I really liked Robin Williams, and then I watched it. I was like, wow. Dead Poet Society was good. There was a kid in there. I forget. Anyways. Oh, yeah. The guy who played Wilson in in House. I really like him. I forget his name. I really like him. I love this movie. Yeah. Yeah. So we're going to do 1 plus 1. You know what? We won't talk about Abacus. We'll just talk about old movies. No. Okay. So 1 plus 1. Why are we doing something easy? We're doing something easy so we're not overwhelmed with all of the beads that we have, right? So what we're going to do is say Never Wilson's name. Yeah, right. It's on the tip of my tongue. I see it and I'm like, yes! And then I forget. I'm like, no. I think it was James. Anyways, I really liked him. I had a crush on him. Anyways, I had a crush on him when he was young. Anyways, so we did 1 and 2. And then I saw him in the house. I'm like, oh my God, it's him. So what we're going to do is we're going to add this one. We have 2. We have 2 here, 1, 2, and then we're going to add the 1. So notice this specific page is always talking about the plus 1. Why? Because I wanted to have the different scenarios, what the 1 looks like. We're only adding the bead. We're only adding the 1 bead. It doesn't matter which bead we're adding as long as it is 1 bead. Right? So, like if we had 2 and then I want to add the 1. Again, I wanted to remind the children, this is a preschool book. And the reason why I did this is because I know that there was a gap in Abacus where we would teach the children that were 5 and older, but I felt like that we need to start younger because Abacus is the greatest thing next to sliced bread, next to Betty White. Oh yeah, that's it! Robert Sean Leonard, yes! Yes! Robert Leonard, yes. Right? Okay, anyways. So we have 7. We have 7, right? How do I know this is 7? Because 5, 6, 7. When we count it, when we look at it. Now, the difference between this and this is that one's a picture and one's real. One is a physical thing. Sometimes the kids have, sometimes the kids have problems relating from the picture to the physical abacus. I would highly recommend purchasing a abacus of some sort or even make one or something that the kids can touch, because when they're looking at it, they'll be able to, even like if you're thinking about doing abacus, if you're thinking about like going through and understanding how to use the abacus, I would highly recommend finding one because it's the greatest thing next to sliced bread. Because when we start moving the beads, we don't have to memorize, we don't have to put it in our heads, we don't have to write it out, we don't have to like think about what we're doing. We just need to understand the fundamentals. When we understand the fundamentals, then it will be easy to move the beads. So a lot of it is the abacus helps us track the numbers. We do the calculations in our head, but when we move the beads, we're just using the abacus to help us track the numbers. Thank you so much for the follow, Candy. And Sandra Flores. Oh yeah, Sandra Flores. Flores, you have 9. We have 9. We have 6, we have 7, and we have 8. So I don't have to think. Yes, I have an abacus, but I don't know how to use it. Okay, Andy, what kind of abacus do you have? Here's a big question. What kind of abacus do you have? Do you have a 10 bead abacus, or do you have a 2 bead and 5? Or do you have a 2 and 5, or do you have a 1 and 4? Yeah. Okay. Let me tell you, you would have to modify your abacus if you wanted to use it the way I'm using it. If you want to use it the way I'm using it, because abacus is the gateway to complex math. All right. So Andy, what I would do, is you would have to modify it. Now, what does that mean? Okay, I don't have one. I think I need to buy one to get this out the door. So we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, what I would do is you have your 10 beads, right? There's multiple, right? I'm only giving you one right now. I would tape 5 cubes together. So I tape them 5 like this. I would tape it 5 and I would leave these ones. So there's the 5. 1, 2, 3, 4, 5. So these ones are moving. Now what's going to happen is you're going to move the abacus 90 degrees. When you move the abacus 90 degrees, right, have a string or have a something and that will be your horizontal bar. So now you can mimic what we have. So we have 5, right? This is 5. We have 1, we have 1, we have 2, 3, and 4. So then I would just kind of ignore this if you can do it. I like turtles. I like turtles too. I used to call my gerbil turtle in Chinese. Anyways, so Andy, when you do it, you can do it. You would just have to finagle it a little bit, or you can buy it. You can buy an abacus like this, but you could do this too because you could see the 5. It kind of makes sense, but you would have to modify it. And then the problem is you'd have this like random one that would be floating around. But you can do it. You can do it if that's what you want, if it's okay with you. But yeah, if you want to do it like that, you could do that, and then you could follow along. Not a problem. Okay, so and then you would have to figure out which one's your 1s, your 10s, your 100s, and your so forth. So I would leave 2 decimals here because then you can actually use it for money. Because our money is like what, 15, right? So if I did 1 penny, that would be 1 penny, 2 pennies, 3 pennies, 4 pennies, and then 5 pennies. That would be a nickel, right? This would be a dime. Right? So that's why I would, if I was to use yours, I would probably have the 2 columns on the side. Yeah, it's possible. Thinking outside the box. So using what you have, because you don't need to buy one if you already have a 10 one. You just have to, it's not even Frankenstein. It's just modify, like, Lightning, was it Cars Tunes with Mater? And he got modified with, when he was doing the Tokyo, I think he was doing Tokyo Drift. I don't know if you guys know that one. I like that one. I like was it Cartoon Tales? Cars Tales, I think it was called. Yeah. So that you'd be doing some modification. Modification! Okay. So we talked a little bit about some old movies. We talked a little bit about some cartoons, and we are going to talk about how does an abacus work. An abacus works with counting the beads. So these would be like a bead, right? So it's a counting tool. When we count, it'll be 1. Oh no, that's 2. That's 2. So then this would be 2. So we have 3, and then that would be 3, 4, and then 4. But then, after 4, counting with Lynette. Yes, Kim, counting with Lynette. So then, how do we do 5? Well, Cami, every time the top bead is always a value of 5, no matter what. So we have 5. This is 5. These are all 5. So if I turn all down, that's all 5. It doesn't matter. But the thing what matters is the place value. So we have the dot, this is the indicator. This indicator tells me that this is the 1s place. So we have our 1s, our 10s, our 100s, our 1000s, and our 10,000. So, thank you for the follow, Andy. Yeah. So what we're going to do is, when I do this is 8. This is 8. Because how do I know? Because it's 5, 6, 7, 8. Sorry, I jumped the gun over there. So we have 5, and then we have 6. So when we do 6, we do this. This would be 16. How do I know? Because there's only these two columns have beads touching this horizontal bar. Does that make sense, Cami? I'm always fiddling around with my camera. So that's just one of the things I have. So we have 16, 17, 18, and 19. So after 19, yes, right? Yeah, I mean, it's great that you're asking questions, because if you don't, then I don't know you're there. So after that, we have 25. This is 25. After 25, we have 26. After 26 is 27. This is just learning how to read the abacus. So we have 27, and then if I did this, it'd be 527. Make sense? And then if I add these two, it'd be 3,527. Make sense? Yeah? Oh, thank you for the rose, Abigail. Let me know if you have any questions. Let me know if anybody has any questions. Even if you have a big abacus, we can talk about it. We can talk about it. Oh, okay. Yeah. Pottery addict. You know what? Pottery addict. I'm live addict. Because I enjoy going live. What about 37? That's a great question. We have 30. We have 7. That's what it would be. Which? Heck yeah, man. Heck yeah. And I was dancing under the moonlight when it was an eclipse. Okay, I just scroll here. I didn't know what it was. You had me, but you lost me. Axel Espinoza. That's pretty easy. So, yeah, not a problem. Thank you, Axel, for your question. So what we're doing is we're counting on the abacus. The first thing we're going to do is we're going to count. 1, 2, 3, 4. That's it. That's it. 4. Now, why do I do that? Because anytime these beads are touching this horizontal bar, we're counting it. So when it's touching the horizontal bar, if you notice, these ones are not counted. So those are all zeros. Whoa! That's not an earthquake. That was just me moving my camera. So we had 4, then after 4 is 5. The top bead will always be 5. The audio is coming through twice, like there's 2 sources simultaneously. I don't know. Oh, I know. How's that? Ah, thank you, Topher. How's that? Better? That's because you sound completely fine on my audio. Yeah. Oh, yeah. Thank you so much. Thank you so much. I appreciate it. Yeah. You know why? Because the last time I got stuck on the ones where you get the tens. Oh, so the tens. So this is 5, right? How do I know this is 5? It was because the last time my mic went out and I had to use my webcam. So going back to this. We have our 5, 6, 7, 8, 9. Notice this is my ones. There's an indicator here. This is my ones. And then here is my tens. So all this is just like how we write. We have our question. Where's my paper? I have a paper. I have a paper to say what a 10 is. I don't have it. I can't find it. Okay. I guess I'll have to write it. Okay. So, going back to here. So if I did 10, when I do 10, just as we write 10, this is my 1, this is my tens, and then this is my ones. I'm very intrigued. Okay, I'm sorry. I'm very intrigued. This is like working out math in visual manner. My brain likes it. Right? Can you do 6942? Yes, Kemi. Ones, tens, thousands. I'm sorry. Ones, tens, hundreds, thousands, and 10,000. Yeah. But the blue ones would be the blue ones. No. Blue ones are all 5. So this is, so we do 5, 50, 500, 5,000, 50,000. Okay, Dallas, we're going to do 6, 9, 4, 2, 420. Rows. Columns. These are columns. So this is my ones, my tens, my hundreds, my thousands, and my 10,000s. I love the number. I don't get it. Why do you love that number? I just got the 6, 7. I don't understand this number. Okay. Oh my God, I got it. Right, Daily? Okay. So, love the, yeah. So when you say rows, we're talking about this way. That's the, so if we were talking about it, it'd be like this. These were all ones, right? And then if we did this would be the rows. I just joined. Hey, Unicorn, pretty cool. But why is the abacus easier than writing it on paper? Because abacus does it for you. And I just learned in the last 10 minutes. Yeah. So we can go further. We'll go further. Writing it on paper, and I was doing a comparison about new math, and the difference between new math and abacus math is that new math is abacus math, but just in written form. And we can actually do that. We will do that. Can you just move up and down versus writing it? Can you just move it up and down versus writing it down? Oh, yeah. So if I did it, right, I'd just be doing 22, 23, 24, and then 25. Is that what you want? I want to learn how to do math on it. Is the new math? Yeah. Well, abacus is not really new. So scrolling through. Thanks. Daily. I'm not sure if that made sense. Abacus is a calculator after all. It's a place to put your, yeah. That's true. Well, your brain is the calculator. The abacus is what just tracks your numbers. So, so we have 135, and then 235, and then if I did this, it would be 5,235. Make sense? But it's interesting because, yeah, yeah. So does that make sense? So then if we do it, so like this one, 6, 9, 4, 20, 4, 4, nope, that's wrong. 6, 9, 4, 20. Could you just expand the numbers on the abacus? Could you expand the numbers on the abacus? What do you mean, like more numbers? So if you wanted more numbers, or we could do the decimal. So if we could do decimal, we had 0.25. So it'd be 0.25. Would not, could. You would not expand the numbers on well if you needed more numbers, you would have to get a bigger abacus. So this is a 13 column abacus, and then this is a 7 column abacus. So you just have to get a bigger, if you have more numbers, you would have to get a bigger abacus. That's what you would have to do. There's this one that I found from Daiso, which we were just talking about it. And so it's the same thing, the same concept. And the colors mean nothing. So when we're looking at it, the colors mean nothing. It's always about the location and the position of the beads. So if this is 5, that's 5. Notice that it's only the top bead. So we have 6, 7, 8, 9. 6, 7, 8, 9. Does an abacus with 10 work the same way, just up to 10 instead? Aubrey, we will have to finagle that. The number only counts what's touching the white line. That's correct, Nguyen. Okay, so, Aubrey, we were talking about it, and he understands. So you had a 10 one, right? You had 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, what I would do, and I've been telling this to a lot of people now, that if you have a 10 bead, what I would do is I would tape the 5. I would leave these 5, okay? And then what I would have to do is I would move the abacus this way. So when you move the abacus and this is taped together, I would have a string or something that would go like this. So then you can move the 5 together, or you could do 1, 2, 3, 4. It might be better. It's up to you. You could use your 10 bead if you wanted to do the abacus the way I do abacus. So I have a bunch of worksheets to do abacus with 1 bead on top and 4 beads on the bottom. I don't use the abacus with the 10 beads, just so you know. But yeah, so like all of these worksheets for like the preschoolers, these are all very specific to the abacus. That is a 4-in-1, not the 10. So if you wanted to utilize the worksheets, you would have to modify your abacus. So I would tape, and then there would be a string or something to figure out where your horizontal line is, and then you can move your bottom beads. Does that make sense, Aubrey? But that's what I would do. I think this abacus is beneficial because there is framework and there is critical analysis. Because what happened is when we're going to start adding and subtracting, we actually have to go through a framework of what we're trying to do. And that was the thing was, when we're learning, we need to understand that we're going to look at the add-in and not, I didn't realize they meant for younger kids. This is awesome. Thank you for teaching it. Oh yeah, not a problem. Abacus, even the 10 bead, I know you could do higher numbers. I just don't know. That's not my field of expertise. My field of expertise is this kind of abacus, and this grows. And even like I started learning this kind of abacus when I was 30 something, before my children. And so this is not necessarily just for young kids. This would be for anybody who wants to do some mental gymnastics, just like Sudoku. crossword puzzles, word searches. I think those are all of it, right? What else was there? What other brain gymnastics can we do? Sudoku, crossword puzzles, and word searches, right? So I want to kind of fit Abacus into this too. So, but yeah, if you wanted to utilize what you have, you can modify it, if that makes sense. But this would not be the, yeah. So again, what we're doing is we're understanding what we're trying to do, because in school we're teaching the kids to focus on the result, whereas what I think we should do and what Abacus focuses on is the add-in, right? This is the second add-in. So in this question we have 7. When we have 7, I'm going to move over here so then we can see. So we have 7, and then what here we have 2. So we're going to add the 2. When we add the 2, notice this is specific to the second add-in. So the idea is to see what happens when you move 2 beads. Then that's all it is. So as we go through it, I mean, I kind of went through the book and stuff, but this one is another question where you answer the question and then you find the answer to the that's on the puzzle board. And then again, if you notice, I have 3. So 3, and I'm always playing around with this. Okay, so I'm sorry. Can make an abacus using cube like that. Plus, I have cubes like the blue ones. Oh, I see. Yes, you can. You can make your own. Let's see. You can make your own. It's possible. It's not like it's difficult. Just make sure if you, Cami, if you wanted to like use one of these, I would do 5 columns. So I do like 2 more columns. This one was just because I was just trying to see what's there, but you could do it, and then you would still have to have a horizontal bar, right? And then there's the counting, right? You're still moving, but then you have to figure out the place value too, right? The spaces, because it would be good to see the spaces. Oh, thanks. But it was just one of those things, like, there's many ways to do an abacus. So this is not the end all, and abacus is not the end all. If you want to make it, then make it. If you want to use the 10 bead and you want to modify it, you could do that too. It's not like, yeah. So I might do that instead. Yeah. Oh, so Cami, when you do, I would do 5 columns. So it'd be like something like this, because then you could do some adding and subtracting, and then you could do multiplication. You could do more, but then I think I would invest in a 13 column abacus. So, but that depends on how much you want to, do abacus. Like, it depends on how many questions you want to do. But like for what we're doing, like this stuff here, it's simple, and you just want to be able to see and move the beads. So here we're adding 3. We're adding 3, and so 3 doesn't have a lot of numbers, a lot of adding numbers. So that's why it kind of goes between here and here. So then I add 1. So I'm adding 1, and my answer is 4. Now, yes, these questions are easy, but the focus is not the result. The focus is the add-in. Why? Because it's when we get to the next one. So like even here, when we do 3 plus 3, 3 plus 3, we do not, in abacus, we do not memorize our doubles. We don't do 3 plus 3 is 3 plus 3 is 6. What we do is we understand the basics. So notice we have a 3, and I want to add the 3. Okay, so I add a 3. So my question is to add a 3. Now the problem is I don't have any more beads to add the 3. This is where we start going into formulas. So what does that mean? Well, that's what the next book is. After we understand how to move the beads, we start going into formulas. And these formulas is what helps us maneuver our abacus. It helps us move the beads, as it just helps us move the beads, really. So we're adding 3 plus 3. So if I find my 3, so notice, again, I focus only on the add-ins. So this one is, let's add plus 3. So the question is, I want to add the 3. Notice I don't have any more beads to add the 3. So what do I have to do? Well, in school, we're teaching the children to how to make a 5. So that's one of the concepts that we solidify, how to make a 5. So when we have 5 is equal to 3 plus 2. Notice 3 plus 2 makes a 5. Well, what we are going to do is we're going to really utilize this idea or this concept. What does that mean? Well, if you notice, we have this 5. This 5 cannot be broken, right? We have to figure out how to use it. But if I add a 5, it's too much. So if I want to do add 3, right? Notice that the 5 is too much. So what do I have to do? I actually have to take away the 2. This is wrong. They gotta go like this. 5 take away 2. I was trying something different. Thank you, Kim. Yeah. So now they're equal. Now they're balanced. So what does that mean? I'm going to add the 5 and I take away the 2. And my answer is 6. So why are we doing it this way? This seems to be so long. It's not. It's the fundamentals, because what happens is when we go to the next one, let's say we did 4. Let's say it's 4 plus 3. We don't do doubles plus 1. We don't need to do that. What we need to do is understand, well, when I add the 3, just like what Kim said, when I add the 3, I'm just going to add the 5 and take away the 2. That's it. That's it. So what we're doing is we're understanding, the fundamentals. We're understanding our basics. When we understand our basics, then we can actually start modifying. We can start seeing if we can jiggle the result. Jiggle the result. I can't figure out that terminology. But anyways, so that's what this is. And notice we can do the same thing for here. So instead of learning our doubles minus 1, I just look at 2 and I want to add the 3. Notice there's that thing, right? It's plus the 3 is equal to plus the 5 minus 2. That's a fundamental equation. That's a fundamental formula. It doesn't even matter what we're doing it. So now we want to add the 3. We plus the 5 and we take away the 2. Sorry, what are the colors representing again? The colors, so the top bead is always a value of 5. Hello, Lavender Warrior. Always a value of 5 no matter what. The bottom beads is not the colors. The bottom beads is a value of 1. So when we count 1, 2, 3, 4, and then when we want to do 5, it will always be like this no matter what. This will be 5 because then we can count on. We can count 5, 6, 7, 8, and 9. I have not worked with an abacus before. The math I learned was a while ago, and it's different. Yeah, I don't know what kind of math you learned. Lavender, I don't know. Have you learned finger abacus? Kind of the same, I think. I don't know finger abacus. I just know abacus. And then I've been trying to relate it to mainstream math. Okay, so this is how we're counting on the abacus. And then when we do, this is my indicator. I have an indicator here that this tells me this is the ones place. So after ones is the tens. So this is 10. And then we have 20, 30, 40. And then 41, 42, 43, and 44. Make sense, Lavender? Okay. Whew. Okay, are we okay? Okay, so we are back to understanding how to add the 5. Does that make sense? So when we were looking at it, there's a bunch of these questions. We're going to do the same thing. 2, or we'll do 4. We'll do 4. Well, what's the value of 4, right? Value of 4, if we look at it, let's do 2 plus 4. We add the 2, and then we add the 4. Do more formulas so we can do 12 minus 4. Can we do more addition? Yeah, okay. So we do 12. That's a good idea. We do 12 and then take away 4. No, plus the 4. We're going to add the 4 and then we could take away the 4. Okay, we can do the subtraction in a little bit. So if we did this one, as Kim mentioned, we could do 12 plus 4. Again, we don't do doubles, right? What we do is we understand that we're going to add 4 to this column. After you're done with addition, could you show me how to multiply? Yeah, we could go multiply after we do some subtraction. So we have 12, and then we want to add the 4. So if I add the 4, again, it's plus the 5 minus the 1. So my answer is 16. So let's take it one step further. Let's take it one step further. Let's do 43 plus 42, right? So, okay, yeah, cool. So again, we don't learn our doubles. What we do is we add 43, right? We add 43 as a whole, and then we're looking this as a whole. We're going to go from left to right. So what's going to happen is we're going to add the 4. We know plus the 5 minus the 1. Where is my... I made this little thing so long ago. Here it is. Is it here? Where is it? Ah, where did it go? I need to find it now. Ah, yes. Okay, yeah. I made this a long time ago where my kids didn't know how to do the formulas. So, I'm sorry. This book is specifically created to use the abacus. Yes, I created this book specifically to use the abacus. Yes, after addition, can you show me natural log, please? I don't know what natural log is. I need the book. Oh, Amazon. It's my name. Here it is. Here's my name. You can find my name. Okay, so what we're doing, oh, sorry, we're here. So 4 plus, we're doing the 42, right? So if I do 43 and I'm doing 42, notice 4 plus 4. I want to add the 4. What do? I plus the 5 minus the 1. So I plus the 5, take away the 1. And then I have 2. And then what happens? I have to plus 2. Plus 2 is over here. Plus 2 is plus the 5 minus 3. So I plus the 5 minus the 3. Isn't that calculus or pre-calc? Oh, yeah. User 7, I don't have your name. I don't have your name. But if you want somebody that does calculus or pre-calc, I would have to find somebody else that does that for you. I know somebody who does algebra. I don't know who does calc. Sorry. I don't do calculus. Yeah, Abacus is the gateway to complex math. That's as far as I go. All right. So yeah, does that make sense? So when our answer is 85. 85. Make sense? So we can do another one. I mean, but again, we don't learn our doubles. What we do is we learn the specific add-in. We learn our specific add-in that we're doing. We don't need to do anything else. So, I mean, even if we made it to a bigger number, even if we did like more add-ins. Okay, let's do this one. Let's see how difficult. No, not this one. Okay, let's try this one. 81 minus 41 plus 44. So in Abacus, what does 1 look like? What does 1 look like? 1. Is that what you're talking about? This one? Okay. I don't know. I'm not sure what you mean, Cami. Okay. So what we're going to do is we're going to, the formula you made. Oh, the formula? That's 1 looks like. So plus the 5 minus the 4. That's what 1 looks like. So if I did 2, it's plus the 5 minus 3, and then 2 plus the 5 minus 2, and then 4 plus the 5 minus 1. Yeah. So this was just a little, this was just a little thing that I made for my kids. And I was like, because they couldn't memorize this. I mean, they started really young, so they couldn't understand. So I made something like this, and I didn't have my worksheets, so they couldn't quite understand what we were doing. Yeah, not a problem. Okay, so we're going to do 81. So we do 81. And then what we're going to do is we're going to take this as a whole. This one is a minus 4. So I had the other one. Minus 4 is minus 5 plus 1. So I got to minus the 5 and then add the 1. And then I got to minus the 1. Is there enough to minus the 1? Yeah. So I'm just going to minus the 1. And then I have plus 44. I want to add 4. So I have to add 4. Is there enough? Yeah. I'm going to add 4. So plus the 5 minus the 1. And then, is there enough to add the 4? Yes, there is enough to add the 4. And that's it. So what is my answer? What is my answer? Anybody know what my answer is? Right, Cami? Good. I'm happy. It's not difficult. It's just something different. Yeah. I gotta retape it. I mean, this thing is like really old. Okay. 84. Yes, 84. Yes, 84. Yes. Thank you, Melinda. 84. Yeah, that's my little thingy. My little flip chart thingy. Okay. So yeah, we can do another one. But then here, what we did is we also doing subtraction. If you notice, we subtracted 4. It's the same, but with just different, what do you call it? Different operators. Sorry, just trying to make my... There we go. All right. So if you notice, when we plus the 4, if you notice, adding the 4 is the same as almost the same as take away the 4. But the difference is we're changing the operators. So you'll see plus the 5 minus the 1, or minus the 5 plus the 1. The operator is flipped. Yes, exactly. Because what we're trying to do is we're trying to take away. When we take away, let's say we're taking away 8, right? When we take away 8, we minus the 5 because we're taking away. So that's the thing that the kids will understand, because when you add, you subtract. When you subtract, you add. So understanding how to do it, right? There's not just one way. So like learning doubles is one way. It's only for adding. It's not for subtraction. But learning the formulas is both adding and subtracting. It just depends on how you do it. So if you look in comparison, I have a plus 4 and a minus 4. The operators are different, right? I'm adding the 5 or I'm adding I'm minusing the 5. It all depends on what we're trying to do here. So if I want to add, I add the 5. If I want to subtract, right, like minus 4, I want to minus the 5 and then I plus the 1. Do you see how that worked? Right? So it makes sense? So this all depends on what we're trying to do. Are we trying to add the 4 or take away the 4? And that was the one thing, like, again, we don't focus on the result. We focus on the add-in. We focus on what we're trying to subtract or trying to add. So when we do this, it makes more sense. Yeah? Oh, thank you for sharing my life. Can we do, let me write it out, 36, 47, and 88. Yeah. Okay, let's do that. So this is a little different because now we're going to go into something that what we call making a 10. So for the first thing I'm going to do is I'm going to put 36. So I add 36 on my abacus. I have 36 on my abacus. Now notice I'm not going to do ones first and then the tens. I'm going to take it as a whole. So now what I'm going to do is I'm going to add 47. I'm going to add 4. I'm going to add 7. There's not enough. So I have to add the 4. Remember, to add the 4, I have to plus the 5 minus the 1. So I plus the 5 and I take away the 1. Now I have to add the 7. Adding 7 is a little bit different. Why? Because now we're talking about a 2-step equation. How do I know? Well, the first thing we got to do is understand how do we add the 7. When we add the 7, there's not enough. There's a formula we need to know. Plus the 7 is equal to plus the 10 minus 3. The 3 and the 7 are pairs. This is something that the kids are learning in school. That 7 plus 3 is equal to 10. This is something that they know. Now we take it one step further. Just like we did with the 5, we're going to take it one step further and we're going to make our numbers work for us. So when we do that, thank you, Kim. So what we're going to do is we're going to plus the 10 and we take away the 3. We want to take away the 3. What do? Well, we need to take away the 3. How do we take away the 3? There's not enough. So what do? Minus the 3 is minus the 5 plus the 2. Now we're done with this. We're done with this. We don't need to worry about it anymore. We're done, right? So the next one we're going to do is 88. Okay. Yes, thank you. Yes, Kim, exactly, right? Makes sense? So what we're going to do is we're going to add 88. We had 8, we had 8. So what is 8? Plus the 8 is equal to plus the 10 minus 2. So adding a 10 always means going to the one column over. That's it. So what we do is we go one column over, we just add the 10, and then we take away the 2. And then we do it again. 88 plus the 10 minus the 2. So what is my answer? Can you see that? What's my answer? Seven, 171. Yes. 171. Yeah, Cammy, we forgot the, thank you, Rob. We forgot the 100. We had the 100, and then we have 5, 6, 7, and then the 1. Thank you, Rob. Thank you, Tani. Yeah, makes sense? Tony. Yeah. So that was easy. I mean, the biggest thing is understanding your formulas. We need to understand how to make a 5 and how to make a 10. When you understand those, then it doesn't matter. Oh, sorry, I didn't see that. Yeah. Yeah, or fat thumbed it. But yeah, I mean, that's the things, like understanding to see how to read. And it because we don't know what we're looking at. Sometimes we don't see what we want to see. So, but I mean, like I've been teaching abacus for more than 20 years. So, yeah, so let me know if you have any questions about abacus. And then again, we can do, so we understand that. Do we want to do some more addition and subtraction? Or do we want to go into multiplication now? We can do multiplication? Yes, I can do multiplication. I can do multiplication. We can do division as well. The first thing we're going to do is find multiplication. Okay, the first thing we're going to do is understand that in abacus, we don't memorize anything higher than 9. It's redundant. So what's going to happen is I am going to have we'll do something easy, right? We'll do 94 times that by 5. So what are we going to do first is we are going to count our decimals. Why? Because on the abacus, our abacus is going to track our decimals. Our abacus is going to track our place values. Count the numbers. Yes, thank you, Kim. So we're going to count the numbers. So the first thing we're going to do is we're going to count. We have 1, 2, 3. So that tells me we count. Hey, Dandelion, we're going to count. So I'm going to be at the hundreds. So I'm going to do a side by side. What does that mean? Well, this is what we call new math, but it's actually abacus. So in new math, they do the same thing. They take 5 times 9. I will look for an abacus in my neighborhood. Thrift shop tomorrow and practice. Oh, yeah. I don't know if you're going to see it in the thrift shop. Try Daiso. Try Daiso. I would pride. Precisely, yes, the number digits calculation. 45. Oh, yes. 9 times 5 is 45. But see, in abacus, we just say this. In new math, they say 90 times 5 is equal to 450 because they write it out. But in abacus, we don't need to write out because my finger is already here. If my finger is already here, it already tells me that I just need to add 40 and I need to add the 5. That's it. I don't need to go higher. Okay, I don't need to say 450 because it says it here already. We're just moving the beads so it's easy for us to understand. So then the next thing we're going to do is 5 times 4. So 5 times 4 is equal to 20. Thank you, Melinda. 20. So again, this is where 5 times 4 is equal to 20. So notice I'm going to add my 2 and I'm going to have my 0. And that's it. But now, if I'm on the new math, we wrote it out. We just write it out. 5 and then 7, 0. That's it. But on the abacus, we already wrote it, so we just need to read it, and then we're done. Does that make sense? So in abacus, we just need to know our multiplication facts, and we're fine. But we don't memorize like 90 times 50, if that makes sense. Yeah. 700, yes, 400, 470. 470 is my answer. But that's the difference between abacus math and new math. It's just that in abacus math, we don't need to write it out. We don't need to write out like extra numbers. We just need to write out. We don't even need to write out our multiplication facts. Ideally, you know it. So all you have to do is just kind of do it like here. I would say 9 times 5 is 45. I had not a 4 and I'd have 5. And then 9 times 9 times 4, 5 times 4 is 20. So that's what I do. How do you know what columns you're supposed to use? So this is my indicator and this is my ones. Can you do that again? Yeah, I'll do that again. So this is my indicator, this is my ones. So when I look at it, my ones, tens, hundred, thousands, and 10,000. So I'm going to do it this way. So let me rewrite it. 94 plus 5. Yeah, okay. So 94 times 5. So we count the numbers to find our place value. Yes, we're going to count our numbers to find our place value. Easy. 1, 2, 3. That's it. That's all we're doing. Why? Because we need to figure out what our place value is for the abacus. 1, 2, 3. The reason why is because when you have single digits, you need to go back one column. So the abacus helps you track the numbers. So we know 9 times 5 is equal to 45. I just need to add 4 and 5. I'm going to add 40. I'm going to add 5. I add the 4 and then I add the 5. I'm going to put my finger here. There is hope for my dyslexia. I'm actually understanding. Oh, yeah. Great, Rob. I'm so happy. Yeah, I'm not sure if this translates well with the dyscalculia and with dyslexia. I'm not sure. I know I've heard of it, like I've heard of dyscalculia, but I'm wondering if the abacus will help it. You know what I mean? It's tactile. Yes, it is tactile, but because like you can do this in your head, right? We know the multiplication are in our head. So my next one is 4 times 5 is equal to 20. So now all I got to do is add my 20. I add the 2 and I have my 0. Did that make sense, Andy? Yeah, I do wonder if the abacus helps your dyscalculia. I do wonder. I don't know too many people that have it, so I'm not sure. But yeah, it'd be great to know more, Rob, if this really helps. But that would be fantastic if you can translate it to that. But that's multiplication. So we can do another one. Let's do another one. Okay, so that's the 5, 10. Okay, let's do this one. We'll do this one. 69 times that by 3. So again, we're going to find our digits. 1, 2, 3. How do I find them? I found them through 1, 2, 3. So that's where I am, right? We count it from the ones, the 1, 10s, and 100s. So now I'm at the hundreds. I have a set of abacus in my class, and I have no idea how to use them. Hey, Sarah, what kind of abacus do you have? Is it the 10 bead or is it one of these? That's always the question I need to ask, because the 10 bead is very easy. Can you do times 33? Yeah, I could do it. Yes, I could do it. Let me do this one and then we'll add the 33. Okay? So we figure out this is our, so the next thing that we're going to do is this, right? 3 times 6. So we do 6 times 3 is equal to 18. Not me thinking the hundreds was 10,000. The individual box, so I need to go check. Yeah, I bet you, and if you want to follow me the next time I'm on live and you let me know what you have, I can tell you how to modify it. Okay, I can tell you how to modify it after this. So 18 plus 1 plus 8. So notice I'm going to move my finger to this one because this is the last number that I touch. This is the last column that I touch. So I move my finger to the top, to the last column that I touch. So my next one is 3 times 9 is equal to 27. Is that right? 27? Yeah. So now I'm going to add my 2. Notice there's not enough beads to add the 2. I don't have enough beads to add the 2. So what do? I need to plus the 2 is equal to plus the 10 minus 8. That's what I have to do. This is a 10, making of a 10 formula. How do I know? Well, because I can't use the 5. So I got to go plus the 10 and then minus the 8. That is what I did with the 2. Don't forget your 7. So I add my 7. So my answer is, hey, Ona. Hey, Bree. Okay, I have one my kids play with, but I don't know how to use it correctly. I have 2 rows and 5. Oh, okay. Miss Beehive, hold on just a minute. So my answer is 207. That's what my answer is, 207. Okay, Miss Beehive, 207. Yes, thank you, Melinda. Okay, let me review a little bit about this one. Okay, so this is what you have. I would recommend to just use the middle. Why? Because it's a little redundant. So we have 1, 2, 3, 4, 5. That's fine. But then we have this 5. So this is 5 or that's 5. And I was like, that's a lot of 5s I have to remember. 5. But then it goes 5, 6, 7, 8, 9, and 10. Which is fine. But the problem is now we're no longer logical. This is no longer the tens place. This is the ones place that just happens to have a 10. That doesn't make sense to me. Then this is also 10. I'm like, what? Now I have 2 ways to know what a 10 is? But then this is also a 10. Okay. 3 times to figure out what my 10 is, that's too complicated. So what I would do, Miss Beehive, I would just use the middle parts. That's what I would do. If that's all right. If that's all right, I would ignore the top. I would ignore the top, and you can use the middles. How do we simple with single digit? I got lost. Okay. Hold on. Let's do it again. We'll do it again. So, Miss Beehive, I would just use the middle parts. So, how do we simple multiplication with single digits? Oh, yeah, thanks. I've always told them it was like counting by tens. Kinda. So, so here, it's easy to count by tens if we have my ones, because I have it indicated. I have an indicator here. So, counting by tens would be here. Ones, tens, 100, thousands, 10,000. So, counting by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 101, 102, 103, 104, 105. That's what I would do. Okay, so let's see. How do we do simple multiplication with single digits? Oh, no. We have to know, Tony, we have to memorize your single digits no matter what. You could, if you really wanted to, do cumulative addition. You could do that, but you have to memorize your single digits, if that makes sense. So here, let's do 4. I have 4, and then add my other 4. Remember, plus the 4 is plus the 5 minus 1. So I'm going to plus the 5 minus the 1. And then I add another 4. I'm going to add another 4. I don't have enough beads to add a 4, right? So what do? Can I add a 5? No, I can't add a 5 anymore because I'm already using it. So then I got to go to my tens. So plus 4 is equal to plus 10 minus 6. So I plus the 10 and I take away the 6. So you would have to memorize your single digits. Yeah. The ones what I'm doing here are the double digits and triple digits. Okay, so let's go to the next one, which was 69 times that by 30. Can I do 34 instead? Would that be okay? Because if I do too many 3s, then people would get confused. Is that all right? Okay, cool. Okay, yeah. So the first thing we're going to do is find our starting point. 1, 2, 3, 4. So, hey, Ethan. So we have our starting point. It's 4. 1, 2, 3, 4. We're at the thousands. I'm going to bring an abacus home and play with it. Oh, that's right. Sarah, so if you if yours is a 10 column, if yours is 10 beads, 1, 2, 3, 4, 5, 6, 8, 9, 10. What you're going to have to do is you're going to have to modify it. Now here's how you modify it. I would tape 5. 1, 2, I would tape 5 like this. And then I keep these ones loose. Then what I would do is I would have to flip it like this. All right. So when you flip it, I'm going to tape it, right? This is taped together. Right? It's taped together. Keep these ones separate because then you have like a string or a pipe cleaner or something, just something like, to keep your track of your horizontal bar. So just like your horizontal bar, you have 5. And then here, so if I add 5, you bring the whole thing down. You add 6, that would be 6. 7, 8, 8, and then 9. That's what I would do. So if yours is 10 beads across, I would have to modify it. I would modify it, if that makes sense. So, yeah. And then you could take it away, right? You could take away 4 or 3 and then take away 5. Yeah, that's what I would do. Okay, so we're back to here. Make sense? Did that make sense, Sarah? Okay, good. Yeah, you're gonna have to. If yours is 10, I'm assuming it is because I don't think there's too many people that have this kind of abacus. It's called a soroban. So, and I should tape it. So that's what I would do is I tape it like this. So you keep it together because this would be 5. And then these would be separate. Okay, so 4. Let's see. 1, 2, 3, 4. Okay. Why not block 5 beads and put the string between the 1 and the 4? You could, but then if you want the kids to see 5, right? It's easy to see that there's 5. But yeah, you could do that. So what Melinda was saying is if you just did this, but then you'd have all of this around. I don't know. You could. I don't know. I think I like to try to use as much as I can. Like you would have this, but it would be one thing to teach the kids that this would be 5, and these would be yeah. That's not bad. That's a good one too. Okay. Ethan, we'll do that one in a little bit. Okay, so we're back to here. 4. Okay. So the first time I'm going to do is 3 times 6 is equal to 18. So I had my 1, I had my 8. Notice I moved my finger. So now, because I did this, I got to do this. 3 times 9. 3 times 9 is 27. So I had 2 plus the 10 minus the 8, and then I had 7. We did that already, right? Now we're done with this. We're going to reassess our number. 1, 2, 3. So now I'm at the third column instead. Yeah, we'll do that. Well, I'm at the third column because I don't need to worry about the 3. So 1, 2, 3. So the next one is 4 times 6 is equal to 24. I add 2, and then I add my 4. How do I add 4? There's not enough beads to add the 4. Thank you, Melinda. There's not enough beads to add the 4. So what do? I can't add the 5. So then I go back to this. Plus the 4 is equal to plus the 10 minus the 6. So I just added the 4. 4 times 6. So then my next one is 6 4 times 9. 4 times 9 is equal to 36, right? So add my 30 and add my 6. So my answer is, hopefully it's 2,346. Yeah? So that's this one over here. 2,346. Okay, so let's do another one. This is my first time on the live. Are the blue bead? Yes, yes, woo woo. Yes, hoo hoo. Blue bead, the top bead has a value of 5. So when we read it, 5, 6, 7, 8, 9. Exactly. So then we have 10. This is 19, 29, 39, 49. This is 4. This is 9. So just like how we have 4 and 5, 45. Exactly. Yeah. Okay. So we're going to do this one. Let's see if I have enough room. I need to have a better, I need to be more organized when I'm doing this. All right. Again, where's our starting point? Yes. Oh, okay. I gotta do this. Maybe I'll do this. Okay. So, we're starting point, right? What's our starting point? 1, 2, 3, 4. 1, 2, 3, 4. I'm over here. Okay. Let's see. Okay. So, the first thing we're going to do is 3 times 1. 3 times 1 is 3. 3. Yeah, not a problem, Miss Beehive. I love the chaos. This is my brain on Abacus. That's, okay. You know why I say Abacus is the gateway to complex math? I don't know if you guys remember, like, they say that marijuana is the gateway to drugs. That's where it came from. All right. Okay. 3 is a single digit. So I go back one column. Simple to use, easy to understand. Yes, thank you, Ethan. So I'm going to add my 3. And now I'm done. So the next one I'm going to do is 3 times 6. 3 times 2 is equal to 6. 3 times 2 is equal to 6. 6 is a single digit. I go back one column. This is my brain on Abacus. I have to remember that one. Add 6. And that's it. I'm done. I'm done with the 3. So now I'm going to reassess. I'm going to figure out where my next starting point is. So I just count. 1, 2, 3. So I count. 1, 2, 3. 4 times 1 is equal to 4. That's not a good color. We'll do black. 4 times 1 is equal to 4. 4 is a single digit. I go back one column. And I add 4. There's not enough beads to add 4. What do? Plus the 4 is equal to plus the 10 minus 6. So I plus the 10 and I take away the 6. I stay here. I don't go anywhere. Then I do 4 times 2. 4 times 2 is equal to 8. 8 is a single digit. I go back one column and I add my 8. So my answer is that correct? 408. I have to check it because sometimes it's like a little late. And I forget my things. Oh yes, that's correct. Thank you, Melinda. Yeah, there was one time I forgot to go back one column and I was like wrong. I was like so wrong. Okay, so that's the answer. 408. Did that make sense, Ethan? Okay. Are we okay? Make sense? Yeah, I started looking at the Japanese, that one hack of the lines and stuff, and I'm like, they're kind of easy. Okay. Yeah, with this one, there's a lot of single digits, so you always have to go back one column. Yeah, that's what I've noticed. You have to go back one column. All right. Are we doing some more division or multiplication? What do we want to do? We can do some more multiplication. Let me find another question. Let's see. Oh, we could do this one. 77 times that by. Restricted to some audience may find some uncomfortable but restricted reasons. Regulated good content. What? My live is not eligible for recommendation and restrict. Because your live does not comply with the For You feed eligibility reasons discussing. Oh, ooh, oh. All right. When did you introduce the green sheet? I just did it today. Oh, 4 and 8. Yeah. Oh, 408. Oh, I don't know 408. That's fake. I don't know 408. I know 420. I came across you in my FYP. You know, it's people are not going to come in anymore because I started talking about drugs. All right. That's okay. It's okay. So we'll keep whoever is here is here. Okay. Yes, 408 is the answer. Thank you. Okay. So 77 times that by 6 equals to what? So the first thing we're going to do, 1, 2, 3. 1, 2, 3. Maybe that's what it was. Okay. We do 1, 2, 3. So 6 times 7 is equal to 42. So I had my 4, I had my 2. And then I do it again. Plus 4, plus 2, plus 4. There's not enough. So what do? Plus 4 is equal to plus the 5 minus the 1. And then I add my 2. Oh, Alma, I just introduced this today because I found it, and this is what I used to use for my kids because they had problems memorizing the formulas. So I hack a little flippy chart thingy. That's what that was. Yeah. People are still joining live. Oh, good. Okay. So yeah, Amma, did that make sense? So these little flippy thingies were because my kids were having problems with the formulas, and so I introduced the thing. Yeah. I mean, these are at least 10 years old. They're not. I didn't just make them. It's been a while, and I saw it. I was like, oh my god, I could use this again. I had another one. Oh, here it is. I had the minus one too. So that's the minus one. And it's the same thing. But yeah, and they were like, my kids were like, are we cheating if we can do this? I'm going, no, it's not really cheating. You just got to look at it and stuff. So, yeah. I just used some, yeah. Anyways. Bree, thank you. Oh, Dandelion, thank you so much for the heart me. And Bree, thank you so much for the heart me. I don't look up all the time to see where the chat's going. Okay, so yeah, so here. 1, 2, 3, 42, and then plus 4 plus 2. So my answer is 462. Most people say 408 instead of 408. Oh. Okay. Oh, thank you for the heart me. To Spain. Anybody have any questions? Are we okay? I didn't know that. Maybe I'm too much of a Californian now. It was a Bay thing. I say 408. Huh. It could. Yeah, I don't know. I'm just thinking like maybe I turned into a Californian because I grew up in I actually grew up in Toronto. But anyways, okay. So the I keep 4262. Okay, yeah. So the answer is 462. There we go. All right, I'm from the 810 though. I don't know where that is. Okay. You want more multiplication? We could do double digits. Oh, we can do this one. We can do 25 times that by 8. So again, it's the same thing. So what we're going to do is we're going to count our digits. So we count our digits 1, 2, 3. So 1, 2, 3, and we do 8 times 2 is equal to 16. So we add 1 and we add our 6. Because my fingers were the last one here, you stay here. So then it's 8 times 5 is equal to 40. So I add my 4 and I add my 0. I add 4. There's not enough. What do? I cannot add a 5. I can't add a 5 because I'm already using it. So what do I have to do? I have to go to the 4 and plus the 10 minus the 6. So I plus the 10 and take away the 6. So my answer here is 200. Now I'm curious. I don't know where 10. I don't know where 810 is. Okay. So that is that. Anybody have any questions? We can do more. We can do more multiplication. Okay. How are we doing? More multiplication? Oh, we can do division if we want to do division. I have a better way of setting it up now. Abacus is the gateway to complex math. Well, I'm trying to popularize Abacus, and Abacus breaks down into manageable chunks. And right now we're doing midnight math. Pattern doesn't change. Pattern doesn't change. Okay. Kind of sort of human. Hello. Welcome. We're going to count. 1, 2, 3, 4. Anytime Oh. It's late for you guys. Well, how often do you go live? I go live pretty often. 2, 3 times a day. 2, 3 times a day. I don't know if you know Lionel Richie, right? 3 times a lady. I also do some really corny jokes like old music and old people movies. And I just relate it to whatever I'm doing. Like, this is my brain on Abacus. Whew. Anybody seen that one when they were kids? With a fried egg? Anyways, I shouldn't say anymore because TikTok just told me that I shouldn't talk about that kind of stuff. But Abacus is the gateway. Abacus is the gateway to complex math. Yeah, so. 408 is California. Interesting. We use O instead of 0. I didn't know that. Maybe I become more Californian. Okay. So, let's do okay, we'll do I don't want to do that one. I'm trying to find a question, that's why. We could do this one. We have this one is kind of nice. This is 19 times that by 9, and what does that equal to? So what we're going to do is find our count our digits 1, 2, 3. So when we count our digits, we do 1, 2, 3. So I'm over here. So the first thing we're going to do is we're going to multiply it out. 9 times 1 is equal to 9. 9 is a single digit. I go back one column and I add 9. And then 9 times 9 is 81. So I add 8 and I add 1. I add 8 and I add 1. I add 8. What do? Not enough to add the 8. So I have to plus 8 is equal to plus the 10 minus 2. So I plus the 10, I take away the 2. And then don't forget, I need to add the 1. I add the 1. My answer is 171. 171. Make sense? Anybody have any questions? Yes, thank you, Melinda. Yeah. Okay. Okay. I've been on for a little bit. Let's see. Where are you? Okay. 99 times 99. Are you ready? Okay. So let's do the last one and then we'll do division. Okay. 99 times. You really like nines, don't you, Ethan? You like a lot of nines. 99 times that by 99. So 1, 2, 3, 4. Nah, I like 7. Then why is there always so many nines? 7. 9 times 9 is 81. Plus 80. Plus 1. And again. Plus 80. Plus 1. I'm done with this. 1, 2, 3. 1, 2, 3. Plus 80. Plus 1. Plus 8. Plus 8. There's not enough to plus 8 here. So I need to plus the 10 minus the 2. And then plus 1. Plus 81. There's not enough. Plus the 10 minus the 2 plus the 1. So my answer is 9801. Is that even right? Let me double check. 9801. Yeah, okay, good. It's not that late yet. Okay. Division. Oh, division. I have a better way of writing division now. I was practicing. I was like, why can't I do this? Okay. Division. Let me move this. Maybe you need a bedtime. Maybe I need a bedtime. No, the last time, it was just the last time, and I think it was just really late. But anyways, let's see. So we'll do something simple. So we do 3, 4, 6. All right. Where is my little tabbies? There we go. My dividend and my divisor. No, Ethan, that one, 27 divided by 8. Well, we could do it. We just got to get decimals. Okay. So, I'm getting better at organizing this. So the first thing we're going to do is we're going to figure out our position. There's 3 dividends. Yeah, okay, we'll do that. 27 divided by 8. So there's 3 and then 1. So there's 3 dividends and 1 divisor. 3 take away 1 is equal to 2. So what's going to happen is I'm at 2. 1, 2. I'm going to put my dividends on the abacus. So here's my answer. Next to it will be my dividend. 2, 4, 6. So now, what am I going to do? Now I need to compare my divisor and my dividend. My divisor is 3. So I'm going to put 3 here. My dividend is 2. Which one's bigger? Happy May. Hi, Happy May. Okay. Which one's bigger? Right. So my divisor is bigger. Because my divisor is bigger, I'm going to utilize 2 digits. These 2. Right? Because 3 cannot go into 2. So the question is, 3 times what is equal to 24 or less? 3 times 8 is equal to 24. 3 times 8 is equal to 24. So I'm going to put my 8 here, right? I'm going to put my 8 here. I take away 20, I take away 4. I take away 20, I take away 4. So 24, right? This is just long division. So now, what do? I have to compare. Who is bigger? Well, what's left? I only have a 6 left. So I have a 3 and a 6. Who is bigger? My dividend is bigger. So that means I got to skip. Yes, Melinda, I got to skip and I got to stay here. So my question is, 3 times what is equal to 6 or less? 3 times 2. So I put my 2 and I take away 6. I put my 2, and I have to bring down the 6. Right? So a 6 and then 0. So my answer is 82. Okay, so Ethan's question, same thing. I have 8 divided by 27. So what am I going to do? Same thing. 2 is my dividend. 1 is my divisor. I have 1 dividend, 1 divisor. So where I'm going to put it is in the ones column. My answer will be in the ones column. I'm going to add 27. So now, who is bigger? 2 or 8? 8. Yes. Okay. Yes. 8 is bigger. So 8 is bigger. I got to figure out with two digits. 8 times what is equal to 27 or less? Thank you. Yes, Melinda. 2 digits. 8 times 3. 8 times 3 is equal to 24. So I have my 3. I take away 20, and I take away 4. Cannot take away 4 minus the 5 plus the 1. So now my answer is 30. I have to transition out. 3 and 3. So who's bigger? My dividend is 3. My divisor is 8. My divisor is still bigger. Yes, thank you, Melinda. So what am I going to do? I gotta have a 3, and I gotta bring down the 0. So it's going to be 30. 8 times what is equal to 30 or less? 8 times 4? No. 8 times 3? 8 times 3 again. It would be 8 times 3, because that's 24. So 8 times 3 is 24. Plus the 5. Take away the 10 plus the 6. So then what's next? 8 times what is equal to 60 or less? 7. So you get 7, take away 50, take away 6, which is another 4. Yeah. And so then 5, right? 8 times 5 is equal to 40. So my answer is 3.375. Yeah, that's what the answer is. Yeah. I mean, we could stop and have a remainder, or we can keep going until it divides out. Ethan, did that make sense, or do you want me to do it over again? I still don't get division. Okay. We'll do it again. But this one's a little bit more difficult because Ethan pushes the class. You get it? Okay. Yeah, okay. So let's do it again, but let me clear it up. Maybe we won't do decimals. Let's do... It was hard with the change of the abacus. Yeah, I don't understand. I don't understand where you are subtracting from. Okay. Yeah, it's harder. It's harder because the... Okay, let me go back to here. So, do you want to do the same question, or are we going to do a different question? Maybe we do a different question. Yeah, okay. So, let's do something like... Can you do an easier decimal? No decimals. Maybe not do decimals. Decimals a little bit tougher. We could do this one. Let's do this one. 8.4. Okay. So, the first thing we're going to do is find our starting point, right? So our starting point is 3 minus 1 because it's our dividend and our divisor, right? And is equal to 2. So I'm going to use this abacus just because it's just easier. So I'm going to start here at the 2, right? Taking away the dividend. Okay, so here is my answer, right? My answer is going to be here, right? But on the abacus, my answer will be here. So because my answer is here, I have to put my dividends here. I put 1, 8, and then 4. Does that make sense? So now I don't have to look at this anymore because it's all here. 1, 8, 4. So then what I'm going to do is I'm going to compare. 2 is my divisor. Yeah, 2 is my divisor. So I have my S and my E. My divisor is 2. My dividend, I'm only going to take this 1, I'm only going to take this digit, and I'm only going to take the 1 digit. It's 1. That will tell me if I can use 2 digits, 2 columns, 2 digits, or 1 digit, 1 column. Yes, because my divisor is bigger, I use 2 digits because you cannot divide 2 into 1. I have to bring the 8 down. So the question is 2 times what is equal to 18 or less? 9. Yes. So because this is a 9, thank you, Ethan. Thank you, Melinda. I put my 9 here. 9 times 2 is equal to 18. So I put my 18. Just as I take away here, I'm going to take away here instead. I don't have to do long division because the abacus does it for me. So I take away 1 and I take away 8. Now this is 0. Now I'm done? No, I'm not done because I still have the 4 to worry about. I still have the 4 to worry about. So now the question is, who is bigger? My dividend, right? My dividend or my divisor? my dividend or my divisor. My divisor, correct. I'm sorry, my dividend. You're right. My dividend is bigger. My dividend is 4. Right. That's the only one that's left. 4. My divisor is 2. So my dividend is bigger. If my dividend is bigger, it's going to be able to come down. So 4, my question is what times 2 is equal to 4 or less? 2. So because my dividend is bigger, I skip one column and now I'm here. So I add my 2, my answer, and I take away 4. So my answer is 92. Wow, there's still 11 of us. Andy, are you all right? Dandelion, did that make sense? Ah, purple pandas. And Prince. And Woo Woo. Hoo Hoo. Rose, Mackenzie, Ray. That's all the people I see. I don't see anybody else. Okay, does that make sense? I don't know. Oh, Dandelion, are you still there? Huh? Yes? Okay. So, we can do another one. Okay. Okay, yeah. I see. Can you do it again? Yeah, I'll do it again. No, you know what? Dandelion, Melinda, I don't see your name in my list. That's why it's so strange. I only see like 6 people on my list. But I'll do it again. Okay, let me do it again. So, 2 divided by 84. 184. So what I'm going to do? Yeah, I don't know. That's why it's nice that you comment so much. Just so I know you're here. Okay, again, divisor, dividend. This is my dividend, this is my divisor. So I'm going to find my... Oh, no, do a different one? Okay. Okay. Let's try... This one would be fun. Let's see. 20... Whoa. 321.9. Okay. So again, dividend and divisor, right? So my dividend has 3 digits. And my divisor is 1 digit. So I'm going to start at the 2. 73. Yeah. Okay. So what are we going to do is we're going to compare. Divisor is 3. I got to change color. Divisor is 3. Dividend is 2. Dividend is 2. So the divisor is bigger. Because the divisor is bigger, I'm going to use 2 columns. One, 2. This is where my answer is going to go. I need to put the dividend 219. So now I compare. Divisor is bigger, so I'm going to take these 2 columns. I'm going to take these 2 columns because 3 cannot go into 2. So I have to take 2 columns. What times 3? You've made the math easier for me, my new gateway. 3 3 times what is equal to 21? Make sense? Because I want to take two digits. One digit doesn't happen. So 3 times 7 is equal to 21. I add 7, take away 20, take away 1. I have to reassess because I still have a dividend. So I have 3 is my dividend, or 3 is my divisor, 9 is my dividend. So my dividend is bigger. I'm only going to take the one digit. I only need to take this one digit. So the question is 3 times what is equal to 9 or less? Because I'm doing one digit, I have to skip this column. So I sit my answer here. 3 times 3 is equal to 9. I take away 9 from my dividend. So I take away 9. So my answer is 73. Yay! Yeah, you got that one really quick. Melinda, that was really fast. Dandelion, did that make sense, or do you want to do it again? Do you want to do another one? Wow, has lit up all the gifts in the gallery. I don't know what that means. Thank you so much for the hearts. The visual steps make division easier to understand for me. Okay, yeah. And that's the thing, like writing it out, trying to organize how to write it out has always been a thing. It made sense, but I wanted to do another one. Okay, let's do another one. Let's do another one. Let's do another one. Let's do another one. Okay. These ones. Okay, you know what? That's fine. Can we see that? So again, do you have a workbook for division? Not yet. But I will. The plan, I have a whole plan. It's just the problem is it takes time to do it all. I'm not confident I can do it myself. That's why. Get on it. I know, right? Stop going live and start working on the worksheets, workbooks. All right. Okay, Dandelion, let me know. Where's my starting point? You tell me. Where's my starting point? I'm done talking. Tell that to my kids. Oh my god. Anyways, Dandelion, what is my starting point? The tens column. Yes. Because it's 3 take away 1 is equal to 2. Tens. All right, now what do I do? This is so about Dandelion. So what do I do? All right, 10 column. What do I do? What's the next step? The next step is put 240. Yes, you're right. So this is where my answer is. Because my answer is going to go in the tens column, because I'm going to put my answer in the tens column, my dividend will be next to it. Because my dividend helps me track the numbers, helps me track the answers. So I have 2, 4, and 6. Exactly. Now what? Excuse me. The next thing I do is compare. What two digits do I compare? 6 is greater than 2. Yes, because my divisor and my dividend. My divisor is 6, my dividend is 2. So my divisor is bigger. What would be the question that I need to ask myself? 6 times what is equal to 24. Exactly. So 6 times what is equal to 24? 6 times 4, right? We add 4. So I add my 4 where my answer is. I take away 20 and I take away 4. Right. I still have a dividend. Now what do I do? I still have a dividend. What do I do? I compare. Yes. 6 times 6 and 6. They're kind of equal. So this one kind of, we know it's going to be 1. 1's a single digit, right? So we're going to go over here. Skip this column and go over here. So we're going to add our 1 because 6 times 1 is equal to 6. 6 times 1 and then take away 6. So my answer is 41. Yep. Ah, thank you, Despain, for the rose. I just saw that. Okay. Yeah, that one's not so good. That's an okay one. Let's see. We can do this one. We can do this one. We'll do 3 digits. We are doing 3 digits. What am I talking about? Okay. Harder. It's the moving back and forth between the columns. Yeah. 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 But it's also just something that that's a thing. I'm not discounting it. I'm just thinking like the kids have a problem with that too. That's why sometimes it's best to say it out loud. Skip one column, eat one column. I don't know why it's so confusing to me. Well, I know it as skip one column, eat one column. So what does that mean? Well, when I do 6, right? I'm eating this column. I'm taking away this column. I take away one column and I skip one column. So when I do it, I tell myself, skip one column, eat one column. So I skip this column and I eat only one. That's how I remember it. Okay. I don't know if I can get a harder one. Let's see. Okay, how about this one? Practice. Your brain is learning something different from what you're used to. Yeah, exactly. It's all about practice. It's that's about it. Okay. 7,553. Yeah, okay. Okay. Dividend and divisor. So I have a dividend is 2. So 3 minus 1 is equal to 2. 2. So I put my dividend 5, 5, 3. And what do I do now? I compare. My divisor is 7. My dividend is 5. So, because my divisor is bigger, yep, I have to take 2 digits. So 7 times what is equal to 55 or less? See, this is why we do or less. 7. 7 times 7 is 49. So I add 7. I take away 4. I take away 9. Minus the 10 plus the 1. Good. So who's bigger? See, now I can't use the what's written. What I got to do is I got to look over here. Who is bigger? And I look at the one column. 7 or 6? My 7 is bigger, so I know I'm going to take these 2 columns. Right. So 7 times what is equal to 49 or less? 7 times 63. I see what you're saying. 63. I got confused. 63. 7 times 9 is equal to 63. So my answer is 79. Yep. Yep. Yeah. I get confused easily. What? Yeah. Yeah, bouncing between the comments. All right. We okay? I mean, ultimately, division is it. But it does get harder. It does get harder when you have like double digit divisors, triple digit divisors. Right. All right. How are we doing? We all right? We're midnight mathing. It's like 11:30 for me. I don't. It's so late for you guys. I can't believe you guys are still on. It's so late. It's like 2:30 for like people over there. Michigan. Isn't it like 2:30 for you? Like in Michigan? I don't know why you guys are up mathing. I'm just saying. I don't think I'd be well. Okay. Anybody have any questions? I'm in Washington. Oh, okay. So you're just up north. Wait. Yeah. You're just right above it. You're just above me. So you're still the same time zone. So it's not that late, but it's still kind of late to do some math. That's like the crazy thing. The crazy thing is like midnight math. Yeah. Yeah. All right. Ethan can't talk because he's in the Philippines. I think it's like the afternoon for him right now. I don't know. I don't know if he's still on. Okay. We can do this one. Yeah, see, it's like the afternoon for him. It doesn't matter. All right, let's see. We could do this one. We could do. Where'd it go? Our dividend and divisor. Our dividend and our divisor. right? So where's our starting point? So the next thing is 3 take away 1 is equal to 2. Decimals? I don't think this is decimals. This is not decimal yet. 2, so I do 7, 4, 8. That's not decimals yet. So then we compare. My divisor is 3. My dividend is 7. So then I compare who's bigger. My dividend, yep, my 7 is bigger. So if that's the case, I skip one column. I move it over here. I skip one column and I eat one column. I skip this column, my answer is here. I'm going to eat only 1. So 3 times what is equal to 7 or less? 3 times 2 is equal to 6. And then I compare this 1 digit to my 3. 3 is my divisor, 1 is my dividend. My 3 is bigger, right? My divisor is bigger. So now I know I'm going to use 2 columns. 3 times, what number is this? 14. 1 and 4. Yep, 1 and 4 or less. So that means I'm going to do 3 times 4 is equal to 12. I put 4, take away 1, take away 2. I still have divisors. This is the 1 divisor. I'm sorry, dividend. This is still the 1 dividend. 3 or 2. My 3 is bigger. So I'm going to take 2 columns, 2 digits. 3 times what is equal to 28 or less? 28. 3 times 7 is equal to 28. No, 9. Is it 9? Oh yeah, 21. Yeah, 9. Where did I put my answer? 7. Oh, ha! I wrote it wrong. This will be 4. Anyways, there's 27. Oh, I see. So then be 1. So then we're infinite. Oh, I see. Decimal. Yep, you're right, because I wrote it wrong. It was supposed to be 738. Whoops. So then my remainder would be 1. Or decimal. But then we'd have to work it out. So 7 times 3... 3 times what is equal to 10 or less would be 3. And then you'd be infinite. So I'd probably do 3.3. So 249.3. Yeah. Yep, because I wrote that wrong. It was supposed to be... But yeah, I see what you're saying. Decimal. All right, it's getting late again. Okay. Now it's time for me to go to bed because I'm not thinking straight. Hey, chef. Okay. Thank you, chef, for the likes. Is there any question before I end? Because now I know I'm tired. Thank you so much, Melinda. Oh, yeah. Okay, anybody have any questions? Good night, Ethan. Have a good day. I'll see you in the morning. I'll see you later tonight. Yeah. Thank you, Purple Pandas. Okay. If nobody else has any questions, I will see you guys all on my next live. All right. Cool. Have a good night. Have a good day. And I will see everybody in the next live. Sorry, Dandelion. Thank you so much. Yeah. All right. We'll do it again. We'll do it again. Tomorrow it is. Tomorrow is a new week. Monday is a new week. Cool. All right. Have a good night, everybody. Bye.